Well, let's get started. So welcome back to method 25, which is the Calc 2. So today we're going to do some review for the first midterm because I got some requests that this Thursday is the first midterm. Just going to collect the review for the first midterm. I don't know what his exact page number is, but that is not the most important thing. So what I would do is just introduce like all the concept that we were going to be covering in the midterm. So with DH 4.9, which is anti-derivative, you find your given the acceleration, find the velocity and the position function. So it's anti-derivative. It's like the acceleration function and the velocity function and the position function. And you're able to solve with initial conditions. We call them initial condition problem. Initial value. This is chat, and this is 4.9. And in 5.1, you can talk about like Riemann sum. It's like the total area under the curve, under the function that is like swiped by region. Use the midpoint, right endpoint, and left endpoint approximation. Approximation of elementary definite integrals. Integrals. This is 5.1. And later, the most important thing is 5.3 is the fundamental theorem of calculus, and the column FTOC is 5.3, and we have two parts. We have part A and part B, part 1 and part 2. For part 1, and we define that a random curve antiderivative antiderivative and which we define that the derivative of function as ddx of x to the a of functions of t dt. It is just fx itself. We have some like advanced version of it. It is like you can change rule when the integral grammar like the functions. ddx of g of x over h of x ft dt. is equal to the chain rule, and the kind of another thing is f of gx times g prime of x minus f hx h prime of x. And then it's net change theorem. Net change is the total distance traveled and total displacement. Only in one note, very important, is while the displacement, you can have a negative, but distance travel cannot be negative. So we must put absolute value sign inside of integral. Perhaps ft is a velocity function because total distance travel can't be negative. Should not be negative. So for tonight, I'm gonna review some concept instead of doing like a lots of example, because like understanding the concept is much more important than just practicing the ton of a problem, but don't know how they are, right? It's important to understand why the answer is this or that. And total displacement, it is just evaluate the depth of the integral because it's negative and it's moving backward. If it's a positive, moving forward. If it's a zero, then make a round trip. Is your position not totally moved? Is it's just the same as like your position after a fixed period of time. A fixed time interval. And this is all 5.4. And then it's the U substitution. And we call it U sub. It is to make a substitution, make the integral easier to solve. And integrating composite functions. Looking for exponent, derivative, composite functions. So this is a type of the example that will go over is like this. For example, it's like is x squared e to the x to the cubic dx. And the purpose of u substitution just to make the integrals like easier to integrate. So that u, because like x cubic has a derivative of a 3x squared, so that u equals to x to the cubic du, it is 3x squared dx. The dx, it is du over 3x squared, and the 3 squared canceled, so we only have eu du. Is this much easier, right? And for all the indefinite integrals, you must have the plus c constant, because any indefinite integral, it is antiderivative of a function. Type number 2, it is inside outside functions. Type number 2, we are looking for composite functions. For example, it is like sine of 10x dx. And we all know like what is the antiderivative of sine, right? So we just so this time we should 10x e to the u. It is inside functions. And we make this move, it is sine of u times over 10 du. And you get something. This is something you're going to see in like on the integration table. So it is much more easier than just to find that. I'm gonna rewrite sine of 10x. It is a whatever and plus a whatever. Don't do that. That's just overcomplicated question. And we just make a substitution. And then it's like a numerator. How about like a numerator to look, no, the denominator. It's like a higher power, or they can make like something like arctangent or arcsine. Inverse trig. It's just more like is the antiderivative of inverse tangent, it is of this is inverse tangent. And some natural log. why there's like absolute value sign inside of a natural log of x, because natural log of x cannot be a 0 or negative. Some arcsine function gonna be arcsine inverse sign. Just make sure pays also attention to the trig functions, inverse trig functions. So there's some like a tricky examples here. It's like we have something like x to 10 minus 2 plus x to 11 dx. And you'll be saying, wow, this is hard. I'm not going to integrate it. No, it's not hard at all. If you take the derivative of like a 2 plus x to 11, the derivative it is 11x to the 10. X10 is going to cancel. It just did. Make the use of. It is u equal to x11 plus 2. Well, they're the same function that, so don't care about the order. As long as you don't write like a x power 11 minus 2, that's just fine. The du is going to be 11 x to the 10 dx. Then we make the differences here. We have 1 over 11, cancel that out, times the u over 1 du. It's going to be about like 1 over 11, 1 du. It's going to be like, it's going to be like in 1 over 11 natural log of 2 plus x to the 11 plus constant of integration. So here's how we do it. So if you see, perhaps there's like the a over m or b over n. If n equals to m plus 1, set u equals to the denominator. In other cases is if is like fx times to the n over 3x times to the m, if m goes to 2n plus 2, set gx a power to the n plus 1 equals to u. So I'm replying to function. I'm replying to message. So if we have something like x to the 20 over 1 plus x to the 42 dx, because 1 plus u squared over 1, it is arctangent, right? Set u equals to x to the 21. And take du to 21 x to the 20. That makes the x of 20 cancel. is a 1 over 1 to the u plus 1 to the u squared, then the antiderivative is going to be 1 over 21 arctangent of x plus constant of integration. So how to do u sub when do integration? Let us make the change of a bound or replace the terms. For indefinite integral, so replace u, just replace the substitute term back to u after integration. For definite integral, make the bound change. Change the bound when making the u substitution. When making the substitution. And now it is error between a curve. It is in terms of a dx, just the top minus bottom. So we have both cases. So we have as if it's case 1, just to visualize this, make life easier. This is A, this is B, and this is f of x, this is g of x. We just color this region that is top minus bottom. Always make sure it is top minus bottom because the area can't be negative. So area, it is b over a over fx minus gx. Case 2 is when the position changes. I'm going to introduce more kind of a common cases you will encounter in a midterm. So cases 2. Is when we have a function, for example, is here. It is A and B. And this is going to be hx, jx. Note that there's like different positions here. Always top minus bottom. So this time over, it's like C, it is like C between A and B. If C it is A and B, and then we just if A smaller than C smaller than B, let's split up an integral. Top minus bottom. So the area total, it is A to the C, it is JX minus HX. And plus from C to B is HX minus GX. So always just make sure top minus bottom. And the third case is when it's like in the term of dy is right and left. So case 3. E to the C, there's a constant. For their m of y over ny. Then the area just right minus left. Left minus, no, the right minus left. So the area it is d to the c ny minus my dy. Case 4 is more of a complicated that we'll encounter. Case 4, but this is rare. It is, you still have this, it's the function. There's D and C here. Perhaps a point H, D, C, and H. It's like those is like a region. Always make sure it's a right minus left. If it's like KX, LX, those KY or LY. So the area, so it's like right minus left, always. So the area, it is HTC it is ky minus ly. Dy then plus h to d is ly minus ky. It's like c h d. They're like this kind of thing. These relations. And the last thing is called like volume by Washer and by Washer and the disk. It is 6.2. So it's like we take those like the slices and then rotate the region by the horizontal axis. So we have this region. And perhaps it is so we take a slice and rotate about a horizontal axis. Make them like a washer. This is just like a washer, just see, this is like a washer, right? This is just like a washer. If you take a look, it's like a washer. And you call them, this is like the area function from A to B. Perhaps this is the x-axis. So the volume, it is pi ax squared. This is rotating by the x-axis. Yes. So the volume, it is b over a pi over ax squared dx. We have a more variation here. As case 2 is if we okay, some new pen. Haha. Case 2. If we're rotating about like another horizontal line, y equals to c, perhaps this is the region well, we have this curve. This is the region a of x. From A to B. And we're rotating, it is y equals to c axis. Perhaps perhaps this line. It is while it is c, it is above. This is y equals to c. If it's this, we have an outer and inner radius. Have this f of x, g of x is the bottom curve. So we have outer radius is larger, so it is so it is c minus the gx. It is the outer radius. Inner radius, it is c minus fx. So this is just about this. We have just rotating the like the regions here. Get it just like a washer, right? It's just like a washer. Right? Is rotating axis. This is kind of like a washer. So did you see? It's like we take a slice of the cross sectional area. For example, it's like t equals to 5 is rotate them about here, and what you get it is a washer here, right? And the volume it is b to the a is pi over outer radius squared minus inner radius squared, then dx. In this case, it's like a c, it is above fx. Case 3, it is if you have a region that is like this, perhaps, sorry, I'm just drawing whatever for the same region. It is we have as h of x, k of x. This is the y equal to c axis. It's gonna be 1, 2, 3. So this is like the resulting for volume, rotating them by the axis. 3, 3. And we'll see this is the washer obtained by rotating this region. This is like a washer, right? Just about this line. And to take a slice, and the figures are not to, and they're not to scale. We'll also just get this inner filling, right? So in this case, it's like the outer radius changes. It is hx minus c. Inner radius, it is kx minus c. Since this just the vertical line, just like, so it is under the bottom function, or it's above the bottom function. So the volume, it is e minus a of pi over r out to the square minus r in to the squared over dx. If the function is like dy, then just change the variable to dy, it didn't change the whole thing. So that's like another, just like another case of like the washer problem. So case 4, it doesn't need to change them into dy. So it's like the last case, and you need to think it is their in term of y. So perhaps, so always like 2/4 like the regions here. Perhaps working by the y-axis. This is like the washer that you obtained by rotating the y-axis. It would be just do you think this is just like a washer? We take a slice from the cross sectional area. We take a slice. It's taking me a while to still paint. This is also the cross sectional area here, and it's going to be from. It's going to be DC. Then the volume, it is d to the c is pi. We perhaps this is kind of AY. dy. This is just like the volume. Okay, I think that will be all because 6.3 it is not really covered. So this is kind of a concept of how you just set up. And for fundamental theorem calculus, I got some requests. So I will make some next videos that I will cover FTOC and some like the volumes. Thank you guys for listening to my videos, and have a good day.